Hello everyone, welcome to AI Anytime channel. In this video, we are going to fine tune the Phi-2 model by Microsoft. I already have created multiple videos on Phi-2, which has been flagged as a small language model, and it's a model that has been created by Microsoft. In this video, we're going to see how we can fine tune that particular model on a specific use case. So if you want to build your own mental health GPT kind of a system using an open source language model or a large language model or a newly hyped word, a small language model, how can you do that? And that's the agenda of this video. We are going to use Phi-2 and we'll have a data set from Hugging Face. We'll also format that data set a bit. So I will give you enough hint that how you can create your own data set, from a corpus of text that you already have, or if you have markdown files, if you want to scrap some data, if you have a CSV file, how can you prepare your data in a format that you can use it for fine-tuning purpose. Now, Phi-2 has already performed well when you compare that with other model on different weights categories like 7B, 13B, and so on and so forth. But Phi-2 is relatively smaller than all of these model weights that I'm talking about. We're going to perform this exercise of fine-tuning in RunPod. So RunPod is a GPU rental provider. You can rent GPUs on a very affordable rate on RunPod. Now let's jump in and see how we can fine tune Phi-2 and if we are able to succeed in the fine tuning. Okay, so if you look at here on my screen currently, I am on RunPod. I have a Jupyter notebook. But if you don't know, where you can use like this Jupyter notebook or how to set it up, I'll show that quickly. Before that, if you don't have any idea about Phi-2, I will recommend you watch multiple videos. Now, you should watch the first video that I created in June 2023, 7 months before I'm creating this video now. Okay, Microsoft released Phi-1. I think I was will be the first of the YouTubers who created a video on Phi-1. And it's around 40 odd minutes and it's completely theoretical. Okay, because their paper textbooks are all you need is really fascinating. You should watch this video to understand the journey of Phi family series, of the LLMs or the SLMs from Phi-1 to Phi 1.5 to Phi-2 and blah blah blah. Right now, the other things that they will coming up in the future. Now, that's the one video. The other video is that on Phi-2, if you want to understand about Phi-2 model, because that's the model, the second version of the Phi model we are going to use for the fine-tuning purpose here in this video, you should watch this video. Of course, the link will be given in the description. If you want to try it out a bit, that okay, let me use the base model and try to generate some kind of responses, you should watch this model where you can try it out in a Colab notebook on in free, which is a Colab environment that you use by Google, where you can use this this piece of code that you will get it from my GitHub repository. If you haven't fine-tuned ever, or you don't know how to fine-tune, okay, and you have no idea of the terminologies like LoRa, QLoRa, PEFT, pre-training, fine-tuning, vocabulary, tokenizers, and hundred of other terminologies, I will recommend you to watch this video of mine, which is more than an hour video. If you have not fine-tuned, don't even ever waste your time to go directly into codes and all, right? That will not help you on the longer run. You'll be able to take my current repository notebooks and you'll be able to fine-tune. But if you really want to learn how it works fundamentally, you should first focus on the basics, and that's what I have shown in this current video that you see on my screen. Fine-tune LLMs for beginners crash course. Please watch this video to understand each and every terminologies that we have seen so far with LoRa's, QLoRa's and others. Now let's jump in and see how we can do it. RunPod, you have to create an account on RunPod, and once you create, there are two options that you can work with. One is secure cloud, the other is community cloud. I go with secure cloud because I want to keep everything secure from data to my compute and everything, my notebooks and whatever. Like when you use community cloud, GPU will be interrupted. Okay, it can be interrupted at any time. So that's why, and community is a bit cheaper when you compare that with secure, but I go with secure because that's even more that's affordable when you compare with AWS SageMaker or some other hyperscalers. Now, different type of GPUs, previous generation, I will recommend you that you go with A100 GPU, 80 GB of virtual RAM, VRAM A100, and that's what we're gonna use here. Now, it's an A100 80 GB, so let's jump in and see how we can do that. So I'm on here on, and once you click on this deploy, it will be something like this. Once you deploy, you have to click on connect. Once you connect, it will show you an option to open a Jupyter lab, and that's what I have opened over here. It's a lab, and within a lab it's a notebook. I already have installed. Let me make it a bit, maybe let me first make it dark. Okay, the theme, and then we'll make it terminal font size. Let's increase it. No, not terminal, sorry, text editor font size. True. But why it's not? This is so bad. Why it's not? Language. Let's refresh and see why it's not able to. Okay, excuse me, sorry, increase code font size. I was in doing a mistake. It's not neither terminal, because terminal you have to go back to lab and open a terminal, or it's neither, or nor it's a text editor. Increase code font size. My bad. Okay, increase code font size. Let's increase it so more you can see it. Maybe you can also handle it through NB extensions and other if you want to do that. But I'm not going to do it. So let me here keep increasing it. We can keep on increasing code font size. Yeah, now it looks better. Okay, so these are the required dependencies that we need to work with. Make sure you install these versions, otherwise you will start getting tons of errors. Okay, if you want to work with fine tuning, I will recommend using 4.31st or 3.1 version of transformers. Okay, in most of the cases that should work. Otherwise, you might get errors on most occasions. So these are the required dependencies. We have PIFT, parameter efficient fine tuning. We have torch as a backend. We have bits and bytes that will help us with the quantization, loading the models in 4-bit and whatnot. Transformers, we need transformer is the backbone of this entire fine tuning exercise. TRL, accelerate, EI knobs, TQDM, SciP. So these are a few things that we need, right? So once you install this, we can start working with our thing. So let's first get import OS. I'm gonna get OS, and then after that, from data classes, I'm gonna have import data class and field. So that's what you need. And from typing, import optional. Okay, this is what we need. And then I need torch thingy. So import torch from datasets. We need Hugging Face datasets here that we're gonna use. Load dataset from, or I can just get it, and let's also load, load from disk. I'll show you that how you can also use this. It also has load from disk. Now you have something on disk also, you can load it, and even from load dataset you can load it your local files. Now from this is right. Now from PIFT, I'm gonna have LoRa config. From PIFT, import LoRa config, prepare model for k-bit training, and then I need transformer thing. So from transformers, import, I need a few things here, so let's get that. Import from transformers, import auto model for causal LM, because it's a text generation task that we are doing. Causal LM, that's the one thing. Then we need auto tokenizer. So let's get auto tokenizer, and then we need bits and bytes config to load the bits and byte thingy. So bits and bytes, excuse me, bits and bytes config, bits and bytes config, and then we need to HF argument parser. So let's get this HF argument parser, and then we need training arguments. This is what we need. Cannot import auto model for causal LM from transformers. Okay, auto model for causal LM, and why is that? Okay, this should be caps. Needs to be caps. What next? Cannot import bits and bytes config. Again, that's seems like a mistake. It should again be caps. Cannot import HF argument parser. That is, what's wrong? HF arguments or argument. ARGUMENT HF argument. This is surprising. HF argument parser. This should be small, I guess. Okay. Fine. So we are able to import whatever we need. This is transformers. Now we need few other things. We need let's also get notebook. So tqdm dot notebook. We need this progress, etc. Right? So import tqdm. This import is done. Now we also need. So we're gonna use SFT here. Supervised fine tuning, SFT trainer, and for that is available in TRL. So from TRL import SFT and trainer. SFT trainer. That's what we need in our imports, and we should also get Hugging Face thingy. So from Hugging Face underscore hub import interpreter login, and then I'm gonna write my interpreter login here. You can also use notebook login, it will work the same way. Once you do that, it will ask you for key. Let me go back and take my key. Okay, so of course I want to take a write and see if that makes sense. I'll keep it no. So I have used a write key with the write access, and I want to see if trust remote code works with that. Now what we are going to do is, let's have a look at the data set. So this is the data set that we are going to use. That's called mental health counseling conversations. It's a question answer basically. It's a question answer data set, and most of the time you will have a question answer data set. If you are working at your organizations, you will have thousands of documents, and so what you have to do, guys, when you have a document, you cannot accept everything that okay, I will just generate, right? You should do a pre-processing and create your data set. I have a video on question answer generator app using both Mistral and also with the OpenAI. That's an application, that's an app. You upload your PDF file, you will get a question answer CSV. So please watch that video. I'll give you the link in description. You cannot have everything in a single video. It's really difficult. So you have to look at different videos and understand the logics, and then build your whatever systems or products you want to build. Now coming back to this, a context and a response here, column name, basically the question answer pairs. You will have a question answer pair. Now that can be anything. You have your natural language to SQL, where you'll be asking a question, generating an SQL query out of it. Or if you have your WhatsApp conversation between you and your friends, you have mental health counseling, you have your insurance officer talking to your end customer. n number of use cases. The underlying concepts remain the same. You just have to understand how it works. You have a question, you have an answer. Question answer pair can be 1000 question answer pair, two columns, 1000 rows, can be 100 million rows as well. That's how Meta and other trains on the petabytes of data, with 2 trillion tokens, Llama 2 has been trained, right? So it depends. Now, if you look at here, this data set has 3.51k rows, around 3500 rows, 3500 question answer pairs. If you look at one of the question, it says, I am going through some things with my feelings and myself. I barely sleep and I do nothing but think about how I am worthless and how I should not be here. I've never tried or contemplated suicide. I have always wanted to fix my issues, but I never get around to it. Now, can I change my feeling of being worthless to everyone? And then there is an answer for that, some doctor or a mental health counselor. This is important. I wanted to take this use case because I think if any one of you want to build a product, maybe something in these lines you can do, because mental health is now being a very common issue or a problem in the digital world that we are currently living in, right? With due to unemployment, due to the inflations, economic conditions, finances, family issues, and whatnot. So mental health is now a real thing, right? So I think we should start talking about it. We should start building solutions that will help fix this problem through different ways. Rather than building an AI girlfriend, you should build an mental health GPT kind of a thing. I mean, I'm just saying. So uh, this is a data set that we are going to use. That can be any data set, and we'll do a bit of workaround with this data set. So let's do that. So what I'm going to do here is, first thing that I'm going to do is I'm going to load this data set. So I'm first writing data set equals, and I'm going to use load data set. So load a data set, and inside this, let's pass our repository. So I'm going to pass this repository here, copy and paste, and then you come here and then you split. So I'm going to say split equals train. So if you look at I'll show you. Now if you look at data here, also says train, right? So split. Most of the time we also have validation and whatnot, right? So let's do that, split train, and then you get your data set. Now it says it's downloading the datasets, have around 3.02 or whatever, and it gets generating train split of 3512 kind of a data rows that it has. Now once you click on dataset, it's a dictionary. It's a context and a response that you see in the features. Now, most of the time we will have a question that, hey, I want a CSV file to work with. Let's convert this in a CSV. Let's make it a more, kind of a instruction format or something like that, where you have a very different format to feed. Because sometimes we'll work with Llama 2 based models like Llama 2, Mistral, Jaifer, and other models. For that, there is specific data format. There's an instruction that you put. If you are using star code or star chat, there is a S that you have to put, the US tokens. Then you have Llama 2 where you have to put instructions and other things in your prompt. Let's do that here as well. So you have a data set. I want to convert this to a data frame, a pandas data frame, and save it locally and then load it and work with it. So now you understand that even if you don't have a data set, how you can take it from Hugging Face and train it, or if you have a local CSV, how you can import and work with it. So let me show the both ways. Now I'm going to do import pandas as PD. So let's do that. And after that, I'm going to do def equals pd data frame. So pd dot data frame, and inside the data frame, I'm just going to pass the data set. And then just do df dot head. If you look at this is the context response. Can I make it even more bigger? I just want to see if I can just increase code font size. Right, maximum is some px value or something, right? Okay, fine. We are able to make it. Now you can see clearly. Now df.head 2, you can see it's a context, it's a response, it's a data frame now. And if you put df.shape, you'll be able to see let me just do a df.info. So if you look at df.info, there is no null value. It both has 35112. The shape is 2 columns and 3512 rows, right? This is what it is. Now, you can also find unique values with value counts, unique and other things. This is fine. Now, next thing that we're going to do is, let me add a few cells here. And the next is, let's create let's create a format of this. So functions to transform the row into a desired format, and that I have my desire that okay, I will convert into an instruction format or any other format, right? So how can we do that? Easy to do. Let's write a Python function for that. So define, and I'm going to do format row. So what I want to do here, guys, is that I want a single column, and I will call it text, and I will feed that single column to that model, and I will ask the model to learn the pattern or learn a new skill about mental health, because we are feeding more context about mental health to the base model, the weights that the model has, right? A very high level. I'm not going technical into it. If you can even make it more pre-trained, like for example, this depends on use cases. For this use case, you can ask me a question now. I'll tell you that video is also coming very soon. If you want to fine tune a pre-trained model for a new language, like for example Portuguese or Spanish or Mandarin, for example, how can you do that? This is not the way of doing it. For that, you need vocabulary. You have to create a vocabulary using sentence piece or whatever. It's a libraries that helps you create vocabularies. Once you have the vocabulary, you will start adding it, to the tokenizer, tokenizer of the model, and then you fine tune on the pre-trained model that you have. So these are intuitive things. So what I'm trying to say here is that different use cases have their own ways of fine tuning process. If you are building it for question answering, some chat models, this is one of the way of doing it. But if you have to fine tune it for different languages altogether, then you have to put the vocabulary, the grammars, the other ways of instructing the model. So please keep that in mind. Now, here in the format row, what I'm going to do here is I'm going to say row is going to take your row, and in the row, let's have a question first. So I'm going to have question equals and row. So if you come here on Hugging Face, this say context. So I want to make it a bit more explanatory. So I will rename it as question. So my question is now nothing but the context. So let's write context over here, and then after question I'm going to write answer. My answer is nothing but that is again a row, and then I'm going to write here, what was that, response. So let's write response. Now my question answer, then I'm going to have formatted string. So formatted string now becomes a string, and this is how I'm going to create. So I'm going to say okay, and this is more of a llama format, but let's do it. So f, and I'm going to write instruction, f instruction, and then I'm going to write my question here. So let's do question and then I end with this as well, instruction, and then my answer. And this is how I'm going to define. Okay. So this is my formatted string. So my question and answer within an instruction bracket. So that's how it is, formatted string. Then return the formatted string. So let's return the formatted string. Alpaca has a different format, llamas have different format, hyena has different format, depends on what kind of model you want to use it. Formatted string, define to formatted string, and then I'm going to apply the function to each row. So let's do that of the data frame. So for that, how we do it? So I'll say okay, df, and then I write formatted formatted equals, I'm going to write df dot apply. So let's do df dot apply, and then I write format row. That's a function that I'm going to apply, and apply dot on x is 1, so x is equals 1. Okay, df formatted. Now let's look at df formatted now. Okay, so df formatted, and you can see now we have around 3, 5, 1, 12 for all are being formatted in a single string kind of a thing. Now let's rename the formatted column to text, and that's what I'm gonna pass. Maybe you can also keep formatted, but it's fine. Now let's do a new df equals very quickly df dot rename. I'm just following what people follow in the industry, columns, and then let's rename formatted to, I'm gonna format it to text. So let's do that, text. Let's keep it in caps. Text. This is how I'm gonna format it. And now let's see new df, and I want to save this for my later reference. And you can see new df, we have text. Okay, now let's only keep text. So we only keep text, we don't need context and response. So let's only make new def equals just double parenthesis and then put your text inside it, and then this will give you, now new df becomes only the last column which is text. So let's do that. And now if you do new underscore df dot head, here you go, you have now text and you have instruction. Let's save that and we will work with this data. Okay, so new df dot head, and now let's save that. So how do you save it? You say new df dot to underscore csv if you want to do it in a csv file, and then you define a name. So let's call it formatted underscore data dot csv. This is how I'm going to define, and then inside this I'm going to say index equals false dot assign an index to it. And now you can see we have a data set here. This is our CSV dataset, formatted underscore data dot CSV. We are going to, and now it's locally available, but we'll use this. You can directly use it from Hugging Face, and you can also use it locally. Now new df dot to CSV. So let's start working with it. So what I'm going to do here is training dataset or something like that. Training dataset. So if this is our training dataset equals load dataset. And now if you look at first time what I did, here I said load dataset directly from Hugging Face split train, but here we are going to load it locally. So it's your choice. And here you can also define the file format. So mine is CSV. If you have JSON, you can do JSON. If you have JSON, you can also do that as well. Now load dataset CSV, and then I'm going to say data files or something. So data files, and then you define your, if you have multiple files, you can pass that in a Python list. You can also do that. Now formatted underscore data, whatever it is, okay, CSV, and then you just split train. Okay, training data set, and you can see it says now training data set to train data set. Now let's load it, and you can see now features, text, whatever. Now here starts our journey with the fine tuning. This was on the data part. So I'll make this more of a markdown to write fine tuning code here. Fine tuning code. Excuse me. Fine tuning code. Now let's add a few cells, not more than now the base model. So we're gonna have a base model. I will write everything and then I will run it. So base model is what we have a Microsoft Phi-2. So I'm not opening it because I memorize it now. So Microsoft hyphen like slash hyphen Phi-2. This is my base model. Now you will have a new model. So that let's rename that new model, because that will help you when you are merging the LoRa adapters. So you have to merge the new model in the base model weights and create a single file that you can upload it to Hugging Face. We'll also see that if time permits. Now new model equals Phi-2, let's call it Phi-2 mental health. This is what I'm gonna call it. Base model, new model. Now you can also name it as according to your choice. Now the tokenizer. So tokenizer equals, let's use auto tokenizer. It should suggest me, and you can see now I want to do shift to do that. Now tab, excuse me, from pre-trained. Auto tokenizer dot from pre-trained, and here I'm gonna pass my base model. That's the model that you are gonna use. So use the tokenizer of the base model, and then use fast. I want to use that parameter and keep it true. This is my tokenizer. Now once you do tokenizer, you do tokenizer that pad token equals to end of stop token, US token. So pad token, and I have covered each and these terminologies in my previous videos. I'm not going to cover this. To understand this better, you have to watch this 1 hour 20 minutes video to understand what is pad token, US token. These are special tokens. What is padding right, why not left, and all of those things. Tokenizer dot EOS token, and then after that what we have is tokenizer dot padding side, and then let's keep it right. Now tokenizer is done. So we are okay with tokenizer. We have our constants of the model that has been defined. We're not going to change. Next thing that you do is BNB config, which is bits and bytes. Very fascinating. Without bits and bytes, if you want to understand more about bits and bytes, you have to, the best thing to learn the QLoRa paper. Upload the QLoRa paper to chat GPT-4 and ask GPT-4 to make you understand each and every line. It will make you understand, okay, in layman terms and everything. So bits and bytes config, and here we're going to use that class that we have of bits and bytes config. And inside bits and bytes config, the first thing that we're going to do is that we are going to load the model, load the Phi-2 model in 4 bits, not in 8 bits, not in other bits, in 4 bits, because we are going to use QLoRa here. So load in 4 bit. So let's keep it true. You have to keep that true. So load in 4 bit is true, and then I'm going to use BNB 4 bit config config style. It is okay, 4 bit config style, not config style, excuse me, sorry, quant type, because we're going to use NF4 quant type. I said config style, oh bad. Quant type. Now this is important. What is NF4, guys? NF4 is normalized float 4. I'm talking about the full form. It's very intuitive, fascinating data type, okay, to understand mathematically and algorithmically as well. NF4 is based on quantile quantization. That's called QQ. Okay, NF4 is, that's based on that. And just see this on a very high level. That's NF4. If you use the default quantile quantization, there are a lot of drawbacks. Now imagine if you, I don't know how to put it. So on a very high level, technically, if you talk about it, this makes your neural networks smaller, in the size. It's because you are going to use a quantization there to make it more smaller, but keep the same performance. Imagine if there's a long line. I was trying to make it layman. There's a long line and a lot of people in the line, the queue, and you're in the quantization step. There is someone who has to create a marker. Now you have to create 2 different lines. There is one line you want to divide that in 2 lines and keep a marker that and all of these people have to stand behind the markers. The selection of marker is something that quantile quantization does, in bits and bytes, if you talk on the very layman terms. But they had a drawback when the line is too long. The quantile quantization, the QQ, were not able to figure out that where to keep the marker, and that's where we started using NF4, a normalized float data type, because it assumes, and it's mainly predictable, that it predicts that, okay, people just think like this, right? NF4 is smart. It's a very smart way of dealing with quantization. I'll tell you how. NF4 assumes that people are smart enough who are standing in the queue, and they will form the line accordingly. That's what NF4 decide. I'm talking very layman terms on a high level, but if you go technical, let me know if you want to understand these techniques in detail in the comment box for NF4 examples and all other terminologies. We'll cover that. Now, NF4, it's a type of quantization, so data type, BNB 4-bit quant type, and the next is BNB 4-bit and compute D type. I'm going to keep float 16, and I hope you know this is very basic. Compute D type, and then let's torch dot float 16. Now this is my D type. Compute data type, which is float 16 of torch tensors. Okay, now BNB 4-bit compute D type. The next is BNB 4-bit, and I'm gonna keep use double quant. I don't want to use double quantization. There's a myth that I am not sure about it. What the next statement that I'm making? If you use double quantization, it degrades the performance. That might be true. Use double quant, so it's a Boolean value, so we'll keep it false. So BNB 4-bit use double quant is false. We are okay with our BNB config. Now what next? So we're going to do BNB config. Now we are going to deal with model. So let's deal with model now. So model, And we're gonna use auto model for causal because it's a text, it's not a mask language modeling, it's a text generation. So from pre-trained, and from pre-trained layer and inside this dot from pre-trained, and I'm gonna write base model. So I'm gonna write base model, which is my Phi-2 Microsoft, and then quantization config. Here is the config. That was the quanti. I made a mistake. Quantization config, and I'm gonna load the BNB config here. So BNB config. Let's load that. BNB config. Trust remote code equals true. Let's make it true. You need an Hugging Face API to make the key, not API. That's the key, access tokens. Trust remote code true. And by the way, for your information, while I am creating this video, Phi-2 does not support flash attention to. You cannot use flash attention to right now for the fine tuning. You can use flash attention, okay, but not the second one of it, flash attention 2. So for that, what I'm going to do is flash underscore attn equals true. Flash attn equals true. Let's keep rotary equals true. You need to watch Karpathy's Transformers video to understand this terminology a bit. He explains really well. Flash attn, flash rotary, we have fused GPU, right? That's fascinating because these are the fused GPU is flash attention to, right? Makes fine tuning easy. When you talk about from the compute and memory standpoint, and that's why we are using these parameters. Now f huge dense equals true. What else we have? Flash attention, flash rotary. I have to look at my notes. Low CPU memory use, we have that. It does not suggest. Okay, how do we do that? Low CPU memory uses or something. Okay, uses equals true. If used, what else we can have? We need to use CUDA. So device map. So device map, and we have one CUDA going on here. So to device map and 0, and yeah, this is what it is. You can also I'll show you. You can also use revision. Now, what does revision means? If let me just write references of commit. So they have so when you push this right on Hugging Face or wherever, there's a lot of commits happen through Git. I'm talking about Git here. PR is pull request and 23 is the identifier of the commit. So I have noted it down. Now this is the specific version or the branch of the model you want to load, and that's what revision means, by the way. That's what I'm also show you in this video. Now device map, low CPU memory uses true. Now here the next is model dot config. I'm going to talk about cache here. Model dot config dot use underscore cache. Let's keep it false. Not required. We need to load it in kbit. Okay, so model dot config dot pre-training. I hope I spelled it right. Pre-training TP equals 1. And then what we have, so let's get the model equals prepare model for kbit training. Yeah, I hope I okay, I have noted. I was just seeing if I have imported prepare model for kbit training. Okay, and here model, and I'm going to use gradient accumulation or gradient checkpoint. Okay, so use gradient to save memory. That helps you save memory. Use gradient checkpointing true. Checkpointing true. This is my model thingy. Now I need a training arguments. A lot of arguments that I have to define quickly. Training arguments, and I'm going to use training arguments. And inside this, a lot of things happens. Okay, so training arguments. The first thing that we're going to do is output directory. So output dir equals, let's call it mental health or something like that, or mhgpt. Let's call it mhgpt. Okay, this is my output directory. Mental health gpt. Now number of training epochs, I'll do it for 2 epochs. Number of training epochs. Let's call it 2. Uh, number of training epochs 2. Number of training epochs 2. Not number of training epochs. Number of train epochs. So num train epochs. Now after num train epochs, what we need is per device train batch size. So I will also keep this maybe 2. And I've covered this. How do you select batch sizes? How do you select epoch in the video of the fine tuning crash course? Gradient, and then you write accumulation step. Gradient accumulation steps, and this becomes your how many steps you want to accumulate the gradients. N number of blocks. Let's keep it 32. Gradient accumulation steps. And what should be your evaluation strategy? And that should be steps. Strategy, and that should be steps. So let's keep it steps. Evaluation strategy, and then what should be the eval steps? Eval steps. Let's keep it 1000. Okay, eval steps. And then you have logging steps. I'll keep it eval steps as 1500. And logging steps. So logging steps. Let's keep it every 15 steps. Okay. Logging steps, and after that I need an optimizer, optim. So let's write optim, and I'm gonna use Adam W8-bit. So page and Adam, not Adam, 8-bit. Optim learning rate. What is my learning rate? So my learning rate is 2e minus 4. Okay. Now learning rate. What else we have? We have LoRa scheduler type. So LR scheduler type. Spelling is wrong. LR scheduler type, and let's keep it. That should be cosine. What else we have? We have safe steps. Safe steps, and I'll keep it 1500. Safe steps, and then warm up ratio and some of the other parameters. So warm up underscore ratio and warm up underscore ratio, and then that goes 0.05, and then I have my weight decay residual weight decay 0.01, and then I have max steps. So I'll keep it -1. If you want to do tensor board MondaB as well, you can also define that. Max step -1. If you keep it 2, that's really maximum steps. Okay. Fine. Okay. Let's. Okay. Now this is done. Now that should be max steps, by the way. Sorry. Now what I'm going to do next is we need 2 more things. We need pift config. So pift config, and this is important when you are fine tuning Phi-2 because it does not support all the target modules. Okay, so performance is very critical when you have to choose the right module in the transformer attention blocks or whatever transformer layers I'm talking about. The blocks, the LoRa config R32 for the scaling purpose, LoRa alpha. It's a smaller model, so keep it a bit higher. If you keep it smaller, performance will degrade. LoRa alpha, let's keep it 64, and that is done. Now LoRa dropout, so let's keep it dropout. So LoRa dropout, and let's keep it 0.05. Now here comes the not now. Let's keep it bias type and task. Bias type should be none, so let's keep it none. Then we have task. So task type, so it's a causal thing, so let's write causal lm, and then task type. Target modules, and in this target modules what we're going to do is I'm going to show you, write the things here that you should try it out. Maybe you can also do your own findings. In my experimentation and the other guys who have done in the community, these are the target modules that we have to use for fine tuning Phi-2. You can also put out projection, okay, projection as well. But if you put out projection, it will take a bit of time to fine tune it, because the parameter goes more than 35 or 40 million, which is too huge. So I'm not keeping that. But these are the target modules for Phi-2 fine tuning. Okay, Phi-2 fine tuning, you have to keep these target modules, but not limited to. Okay, I think we are fine with this. So FC1, FC2, and WQKV. What are these things? Please watch my fine-tuning video. Explain that. How do you find out all the target modules? What are those means and all. Now, PEFT config is done. Now let's create our trainer variable, and we'll use that to train SFT trainer. And in SFT trainer, I'm gonna pass my model equals model. So let's do model equals model train underscore dataset. So train underscore dataset equals training dataset. That's our dataset name here. Training dataset. And then PEFT config. So let's write PEFT config. And then you go PEFT config. And after that, you do a dataset underscore text field. What is the text field of your datasets? And our is in text column, so T is capital. Okay, so text, and PEFT config is done. It is the maximum sequence length. This is very important. See, I am just showing you how you would do it, so I'll keep it small, but all of these things you can configure according to your expertise or choice or the use case. So please don't just copy and paste the code. So max sequence, let's keep it around 690 or something. Okay, max sequence. And then tokenizer equals tokenizer, and then what we have args. So args is nothing but the training arguments. Okay, so we have training arguments that we have defined over here. This is what it is, guys. So what I'm trying to say here is that these are configuration that I'm showing you. Okay, you should increase the number of epochs, dataset size, the max sequence size to get the best performance, to get the best out of your fine tuning. These are not the best fine tuning result that you will get, because I have limited memory, I have limited compute, but I'm showing you that how you can fine tune Phi-2 model, okay, Phi-2 LLM or SLM or whatever. Now let's run it and see if we are getting any error here. And you can see it's downloading the model. It will take a bit of time because it's a bit like it has to download 9 GB of files. I'll pause the video here. I will come back once it is done. All right, so you can see now the models have been downloaded and loaded also. Downloading is not the big deal. Loading is the big deal, because that's where your GPU gets consumed. Now, there was two mistakes in my writing when I was writing it. The one was the memory uses. It will be mem uses, low CPU mem uses. That was the mistake that I had. The other mistake that I did something where some other like spelling mistake with scheduler or something. That was the two mistakes that we had. Now we are okay with this. Now we have to train it. So we have to do trainer.train. So let's do trainer underscore, not underscore, dot train. Now this will take time. This will take you, like for this, on 2 epochs on this data set, for this sequence length and batch sizes, whatever we have, it will take you probably 40 minutes, 35 to 40 minutes on 2 epochs. Now once you hit trainer.train, what I will do, once I hit trainer.train, I will pause the video. I'll come back once the training is complete. Now let's see that. So you can see it's has started. Initially it will be a bit slow, and you can see now we have 2 by 108 and epoch 0.02 of 2. So it has started now. It has a step, training loss, validation loss, whatever, and it's gonna give you the result, okay, of all the training fine tuning exercise that we have, mainly the description, the verbose description of it. So let me pause the video here again and come back once the fine tuning is completed, guys. As you guys can see that fine tuning has been completed and we got around 2.37 as a training loss. Fair enough, we have to bring it down. Okay, we have to bring this training loss further down. And maybe we can do that by different configuration, of course. And we have to train for a bit more epochs because the training steps also plays a role. So that's also something we have to track it down. Now you can see we have fine-tuned it took all the descriptions, training output, global steps, training loss, the matrices. You have your metrics, training runtime. What was the runtime that it took? Training samples per second, train steps per second, total loss, train loss, epochs, and whatnot, right? So 1.97. Now, so you can see 108, 108. So now you try it out and let me know. In the next video, what we will do, we'll inference it and we'll also merge the adapters and we'll create a single model because I don't want to do everything in this video. It'll become too big already. It will be around 45 minutes or something. So in the next video, we'll inference, we'll create a Gradio app and we'll try to evaluate this model that we have fine-tuned further and see what kind of responses we are getting. Now, that's all for this video, guys. I hope you liked the video. You understood that how you can fine-tune the Phi-2 model. The Phi-2 is small language model using SFT. And if you have any thoughts, comments, please let me know in the comment box. The notebook will be available on my GitHub repository. You can take the notebook from there. You can try it out yourself on your data sets. And if you have any doubts, please reach out to me. You can reach out to me through my social media channels. You can find the information on the channel about us and the channel YouTube channel's banner. Okay, that's all. If you like the content, please hit the like icon. And if you haven't subscribed the channel yet, please do subscribe the channel. Share the video and channel with your friends and to peer. Thank you so much for watching. See you in the next one.